I'm Alice Gibbert, so I'm working at Aerospace Valley with Aurélie Becker, the manager of the ISABIC South France. And I'm glad to welcome you today for this webinar, which is part of a series dedicated to the promotion of our alumni, and we try to present their activities and their evolution. And today we're welcoming François Mercier-Tigrine that will be presenting HD Rain. So in a few words, just not to spoil you, HD Rain is a company that is offering high resolution measurements and forecasts, and it's based on the deployment of sensors and the use of dedicated algorithms. He will present it much more better than I will do it. So just a few practical information before we start. The first part of the webinar will be dedicated to the presentation of HD Rain's activities and experience as a former incubated at ISABIC South France. And then he will answer to all of your questions during a question and ask session. So you can write down your questions on the tab. You'll see it's on the right side of the screen. And I will read it out loud so we can answer it. So that's it for me, and I wish everyone a very good webinar, and I leave the floor to François.
Thank you very much. So yes, I am from HD Rain. So I'm François, and I am the chief of science at HD Rain. So HD Rain is a 4 years old startup which offers high resolution weather measurements and forecasts. So in the very first part of the presentation, I will introduce the needs associated to this kind of data. So as everyone knows, climate change causes massive disruption. So there are more and more people subject to high floods. They live in flood zones, and the floods, for instance, costs a lot of losses every year. And so existing weather observations are not always enough to cope with these difficulties. So here are a few limitations of the existing rainfall observation system. So it does not mean that these systems are not very useful, but it's just to illustrate their limitations. So for instance, the weather radars which are used to monitor the rain cells are very expensive, so that they are only available in a few countries around the world. It can be from 1 to 5 million per weather radar, and for instance, over France, there are about 25 weather radars. Of course, this data are scattered. If you use satellites to measure rainfall, it's quite low in spatial-temporal resolution. And as I said, a lot of territories do not have this kind of instruments. So HD Rain provides a new technology to measure and predict especially rainfall and also over weather data such as temperature, humidity, or pressure. So this is the main principle of our innovation. So actually we build sensors in order to measure the power of the signals coming from television satellites. So we use classical TV dishes, which are used to get the television from satellites. And then we just add a little sensor, an electronic sensor, which is connected to the TV dishes and which is able to measure the power coming from the satellite. And the important point is that at the frequencies these satellites emit their signal, these waves are attenuated, faded, by the raindrops that they emit during the cross of the atmosphere. And so when we measure the power coming from the TV satellites, we can see a decrease of this power when it is raining over the ground satellite link. So we measure this decrease of power and we translate this loss of power into a mean rainfall rate over the link. So finally, we install a set of sensors, of such sensors, so TV dish plus electronic box, over an area of interest. And then we combine the measurements, the rainfall measurements coming from all the sensors of the network in order to retrieve in real time the rainfall maps, the maps of the rainfall falling on the area. And then we produce short-term rain forecasts, so it's nowcasting, by interpolating in the future the mean moves of the rain cells during the last 2 or 3 hours. So our electronic boxes are self-sufficient in energy. They have solar panels that are used to provide energy to them, and they transmit that data using 2G or 4G, so they can be installed potentially everywhere around the world. So here is just an example of the measurements we can make. So here on the top, the blue line represents the power received from a satellite. So this was in south of France during last summer. So you can see in blue, so the unit is in decibels. So you can see in blue here in the beginning, the signal coming from the satellite is very constant. And then here it starts decreasing a little bit by 1 dB. So this means that here there is a little bit of rain. Then it stops raining here. So the signal is constant, quite constant here. And then it suddenly decreases here about 7 p.m. here from about 12 decibels and here again. So this means that here there have been small rain and here a stronger storm, stronger rain. So what you can see here is that the mean power received from the satellite is quite constant when it's not raining, but it's not totally constant. For instance, here there is a little loss of signal that is not due to rain. So what we have done is that we have trained a neural network in order to detect the moment it is actually raining over the link. So our neural network, once it has been trained, so in France it has been trained with radar data, and in Africa it has been trained with data labelized by ourselves. And so the neural network is able to say that here it's not raining, here it's not raining, and here it starts raining, and here it's the end of the rain. And after this, we draw the red curve that is the power that we would receive if it was not raining. And so then the gap between the red and the blue line is the loss of power specifically due to rain. And this is this loss of power that is finally converted into rainfall rate using classical literature, scientific literature tables. And so at the end of this process, for this link, for this sensor, we have the time series of the rainfall rate over the ground satellite link, here in green on the second plot. And so we combine the data, such time series coming from all the sensors installed on the ground in order to produce the rainfall maps. And this is done by a data assimilation algorithm. So this is a short presentation of the products that we have. So we offer rainfall maps, quite accurate because we install a lot of sensors, about 50 meters in space. We offer forecasts, so it's up to 2 hours. Of course, it depends notably on the topography. It works quite well in the plains, and it works not very well in the mountainous areas because the forecast is nowcasting, so there is no physics in this. We just suppose that if a rain cell moves it towards the direction during the last hour, it will still move in the same direction during the next hour. And it's of course a real-time process. So our main expertise is in rain. So we offer rain measurement and predictions, but we also add sensors of temperature, humidity, and pressure in our sensors in order to offer information about this data. And so our data can be accessed by a web application or in the next month from an API. So this is a little history of the science behind the HD rain. So actually, this technology has been first developed in Paris-Saclay laboratory, the LATMOS. So Laurent Barthès and Cécile Mallet were my PhD directors, and they started working on this topic about 10 years ago. Then I worked on the rain maps retrieval, and we have created HD Rain 4 years ago now with Ruben Ali, another PhD in weather science, and Duminder Ratnayak with the hardware specialist, the electronician of the team. And so we work still closely with the LATMOS on scientific partnership, and we also work with IRD, the Institut de Recherche et Développement, notably for international deployments in Brazil or in Ivory Coast. So this is a visual comparison between a rainfall map that we have retrieved from our sensors on the left, and that has been measured by the radar of Météo France on the right in the Bouches-du-Rhône in last October. So at this date, we only have about 20 sensors in this area. So just to show that with a limited number of sensors, we are able to produce rainfall maps. So this is just the beginning of a massive deployment. So we are currently setting about 1,000 sensors in the south of France. So today we have about 300 sensors already installed. So the one in green here and more in the Alpes-Maritimes. So we work with the firemen buildings in all the departments in the south of France to install these sensors, and we also have sensors installed abroad. So we have about 150 sensors around Abidjan in Ivory Coast. So it was a project for the National Weather Service of Ivory Coast, and we also have sensors for agriculture, also in Ivory Coast, but in a rural area. I will say a word about it just after. So here are two examples of applications for this data. So what I want to show here is that the measurements, the rainfall measurements, are actually probably as much important as the rainfall predictions. It's important to have data from the past to understand the phenomena. So we worked with Alliance in the south of France, near Antibes. So their problem was a lack of data, and the lack of data in order to understand the relationship between the recorded flood claims and the rainfall in the concerned areas. So we installed about 20 sensors near Antibes, and we studied the correlation between the measurements made by these sensors and their disaster database. And so the impact was a map of the rainfall accumulations and the risk in real time in order to better manage the inflows of claims in the flooded areas. The second example is drastically different. So it's for the agriculture in Ivory Coast. So it's near San Pedro, which is a city in the southwest of Ivory Coast. And our client was Touton, which work on the cocoa trading. So they had a lack of visibility on cocoa harvest, and their wishes was to have information about rainfall, statistics of rainfall on long term, so in months or years, in order to anticipate the price of the cocoa for the next year. So we installed about 20 sensors in a large part of their cocoa area, and with this data, they can optimize and anticipate the quality and the quantity of the cocoa harvest, and so to anticipate the turnover and sustain the farmers' income. And so now they want to extend the system on the rest of their cocoa areas. And just 2 slides to conclude. So this is our team. So we are both in Paris and in Toulouse. So in Toulouse, we have our CTO, Dominda, which is responsible for the hardware part and for the application also, the developers. We have 4 developers in Toulouse. And we have a team of three scientists. So myself, Jordan, who is data scientist, and Maxime, who is another PhD in hydrometeorologist, and Camila and Ruben for the commercial part, Jad for communication, and that's it. And so just to conclude, we had several prizes. So we were winners for iLab a few years ago, and we just won with VH as the prize for the startup of the year last year. Okay, so thank you very much, and I will be very happy to answer your question and to detail different points of the presentation.
Thank you very much, François, for this very clear presentation. So for all of our participants, you can write down your questions on the tab. Okay, so we'll just wait a few seconds. I may have a question for you, François,
Okay.
regarding the exploitation of your technology in developing countries. You showed some use cases abroad. Do you have like already signed contracts in developing countries? Because I believe that it could be very useful and really adapted to those kind of needs for countries without any infrastructures.
Yes, so our main contract in developing countries is with the National Weather Service of Ivory Coast, the SODEXA. So they wanted to have a system that is able to monitor the rainfall, but without using a radar. So the goal for this is really to produce the kind of rain maps that you can have with a radar, but without a radar. So it does not mean that we do everything that a radar can do, but it's really useful for countries like Ivory Coast. We also have this contract with Touton for agriculture in Ivory Coast, and the third important one is in Georgia. So it's a contract with the municipality of Tbilisi, and it's a contract together with Suez and with Tenevia, which is an hydrology company from Grenoble, in order to prevent the flash floods in Tbilisi. So we bring the rainfall measurements to the hydrological model. The hydrological model anticipates the floods, and then Suez designs the equipments in order to cope with these floods.
Okay, thank you. Oh, I believe we have a question. Okay, so we have a question. Can you offer an international service partnership if we wanted to offer rain forecasting predictions for live events such as sports or music? That's a good one.
Yes, so yes, we can. Actually, there is an important point to note. It is that if we want to produce forecasts, for instance, 1 hour forecasts, we need to install sensors not only at the point where we want to have the forecast, but also upstream in the direction from which the rain comes. So for instance, in France, if we want to produce forecasts in Paris, because the rain generally comes from west, we would need to have sensors from Paris to Rouen or to Le Havre. So if we want to produce forecasts for a particular point, it can be quite an important investment to install maybe 40, 50 sensors all around. But for instance, near Abidjan, we already have 150 sensors, not only in Abidjan, but far to the east of Abidjan, in order to produce these forecasts. And so we could have forecasts for a sport or music event in Abidjan. We could have forecasts for a sport or music event anywhere in the south of France. Yeah.
And if you need to deploy those sensors, for example, for live events, how much time does it take to deploy those 40 or 30 sensors? Just to have an idea of the calendar.
Right now in the south of France, we are deploying about 20 sensors per day. So it can be quite fast, but if we know where to put the sensors. So in France, we have strong partnerships with SDIS in order to install sensors there. So it's really quick. Once we have a dedicated building on which to install the sensor, it's about 1 hour per sensor. It's more difficult, of course, if we go to an area where we know no one. If you say tomorrow we need to deploy 40 sensors in another country, it will take maybe 1 or 2 months in order to get the places where to install the sensors. But in France, it could be very, very fast.
Okay, good to know. We have another question. Do you intend to extend your expertise to wind or sunshine forecasting to meet the needs of renewable energy?
Yeah, so we don't have tested this, but we would like to. So for the sunshine energy, actually, we will measure the radiations from the sun with our new sensors. So we have the hardware for this. We don't have developed the software, but it will be done in the next weeks or months. So we will measure in the south of France, for instance, on 1,000 points in real time the sunshine energy. So we will be really, really happy to work with a company which is able to use this information, for instance, in a project, in a R&D project together. For the wind, we don't directly measure the wind with our sensors, but again, we will have a pressure sensor in our hardware. And so we'll be able to provide 1,000 points of measurement for the pressure, the sea level pressure, in the upcoming weeks or months. And so we think that it could be very interesting to measure wind, for instance, by assimilating this information in weather, in numerical weather models. And I think we can improve the measurement and predictions of wind with these pressure measurements.
Okay, thank you. I hope that it's answering the question. We're waiting for the next one. So the first question was Ireland-based for the forecasting predictions for live events. So yeah, that's true that there is a lot of rain in Ireland and it will be kind of useful for your football match or live music events to know in advance. Maybe there is something to do over there. On the side of, you've talked about partnerships and maybe the fact that your tool can complement other space-based applications, because there are also lots of providers today in the space industry, even in the ISABIC network, that are actually addressing the market of renewable energy. So that's true. It could be actually interesting if you could reach out if you're from this sector of activity. Ruben, so Ruben or François can answer your question. You have the contact on the slide. Yes. So do not hesitate to reach afterwards. Thank you, everyone, for participating. And thank you very much, François, for the presentation. As I said just earlier, if you would like to know more about HD RAIN's activities and potential partnerships or innovation project that you could actually lead with HD RAIN, do not hesitate to reach out, and see you soon for the next alumni webinar. Thank you, everyone, and see you soon. Bye-bye.